Okay, the next set of questions come from section 10.4, where you're to write the equation in standard form if necessary, meaning if it's already in standard form, you don't need to do that. If you do need to put it in standard form, recall that you can either complete the square or you can use your TI-83 or 84 graphing calculator. Then, after you've got it in standard form, you're to find the vertex, the axis of symmetry, the domain and range. We're not going to find x and y intercepts, but we are going to find the direction of the opening and, of course, describe any transformations. And then when you graph, we're just going to sketch it. We're not actually going to use a table of values. All right, so problem number 15 is in standard form, and that means the vertex can be found by taking the opposite of the quantity squared. So the opposite of positive 1 is negative 1 as your x value, and then your y value is the 3. Remember, the x value is the h and the y value is the k. Okay, so there's your vertex. Your axis of symmetry is the equation x equals a number, and it's x equals h, which is the x coordinate of the vertex. The direction, since your A is negative, the direction will be a parabola facing downward, opening downward. The domain, if you recall, for all quadratic equations will be negative infinity to infinity. The range we'll have to find once we sketch the graph, and the transformations, recall that they come from either looking at the equation and finding out what they move left or right, up or down, or recall that it means how did it change, how did the vertex change from the origin? Where did I move from the origin to get to the vertex? Well, in the x value, instead of 0, it's negative 1, which means I moved 1 to the left. The y value, instead of 0, is 3, which meant I moved up 3. And those are the transformations. Of course, you can find it from the equation as well. Take the opposite, and that's the x direction, so negative 1 is left 1, and the outside term is the y direction. It's positive, so up 3. Either way. All right, so now we'll actually sketch our graph. Okay, so first plot the vertex, so negative 1, 3. And since we're just going to sketch, we know that it's a parabola facing downward, so from here we're just going to draw a curve facing downward. Okay, and now the range. Remember, we look from the bottom to the top, meaning we're looking vertically for the y's. That's the range is the y's. So the smallest value y can be, as you see it keeps going and going, is negative infinity. And the largest that y can be is positive 3. And you've done everything you were required to do for that problem. Let's do a couple more. Number 14, you'll notice that number 16, is not in standard form. You can use your calculator or completing the square to get it in standard form. I will go ahead and complete the square since we don't have the calculator use here. Okay, so we'll factor out the 5 from the first two terms. Put a blank. We don't move the 25 to the other side, we just move it over and put another blank. So let's complete the square. Half of 4 is 2, and 2 squared is 4. Well, the number I added is going to be 20, 5 times 4. So with putting a quadratic equation into standard form, what we need to do is add the opposite in the second blank. So since I added 5 times 4, which is 20, I need to add negative 20 to cancel that value. All right, so all we have left to do here is to factor. So that's going to be x plus 2 quantity squared, and add plus 5. Now it's in standard form. We can find vertex, axis of symmetry, direction of the opening, domain, range, transformations, and sketch our graph. Okay, so the vertex. The opposite of the x quantity, negative 2. Bring down the y value, 5. Axis of symmetry, x equals the x of the vertex, negative 2. The direction, since A is positive 5, the direction means the opening will be opening upward. The domain is always negative infinity to infinity. The range we'll find from the graph, And now look at the transformations. So from the origin we moved 2 to the left and 5 up. So let's graph. So 2 to the left and 5 up. That's my vertex. Since I have a parabola facing upward, I just draw my curve. And now let's look at the range. The range, remember we're looking the y's from the smallest to the largest, so the smallest y can be is 5, and the largest y can be is infinity because it keeps going and going. Okay, next problem. Is it in standard form? Yes, it is. So what do we need now? Well, we can just find vertex, axis of symmetry, direction of the opening, domain, range, transformations, and a graph. Okay, so the vertex, the opposite of the x is positive 3, bring down the y, positive 5. Axis of symmetry, x equals the x-coordinate of the vertex. Direction, the number in front of that squared term is a positive 1, so that's going to be opening upward. The domain, all real numbers. The range we'll find from the graph. The range, the transformations then, what did we move the vertex from the origin? Well, we moved 3 to the right, and we moved 5 up. Okay, so now let's graph. 3 to the right and 5 up is this point here. And now since it's a parabola facing upward, just draw your curve. And now we can find the range. The smallest y can be is 5. The largest y can be is infinity. Okay, one more of this type. Is it in standard form? No, so we've got to complete the square to get it in standard form. Factor out a negative 2 from the first two terms. That gives you x squared minus 4x plus a blank. Bring the constant over plus a blank. Okay, so half of 4 is 2, squared is 4. Well, what number did I add? I added negative 8, so I need to add the opposite of negative 8, which is positive 8. Factor, add, and you're in standard form. Now we can find the vertex, axis of symmetry, direction, domain, range, transformations, and of course the graph. The vertex, the opposite of the x, is positive 2. Bring down the y, negative 2. The axis of symmetry, x equals the x-coordinate 2. Direction, the a is negative, so therefore it will be a parabola that opens downward. The domain is always negative infinity to infinity. The range we'll get from the graph. The transformations. Look at the vertex. How did it move from the origin? It went 2 to the right and 2 down. Okay, so now let's graph. 2 to the right and 2 down. There's the vertex, and it's a parabola facing downward, so draw your curve. Now you can find the range. The smallest y can be is negative infinity. The largest y can be is negative 2. And that is section 10.4 review.